Hello everyone! It's the 7th of October, which means it's time for the 7th Leetcode challenge. Let's get straight into it. This one is called rotate list. And I've actually checked it beforehand, just as a disclaimer. So rotate list. Given a linked list, rotate the list to the right by k places where k is non-negative. So this is we have this constraint. We know this for a fact, so this is helpful. We do not know if the head is not null though, so we'll probably have to do some validation ourselves. But yeah, anyway, what does this mean is basically if we have this linked list 1, 2, 3, 4, 5, we want to rotating it would mean taking the last one and putting it in the front. So pretending it's a circle, we just rotate this circle and k number of times. So in the first step, this would mean put the 5 at the beginning, and in the second step it would mean put the 4 in the beginning, which would produce the output for 5 and then the rest of the list. And we also have the case where k is higher than the number of elements, so 0, 1, 2, this means 3 elements, and k is 4, and we basically end up with just the 2 being placed here after doing it first 4 times. So thinking about this, I think it's a very interesting case because it allows for some premature optimization. But what I mean by that is, since regardless of how much higher it is than the number of elements, so right now here it's 4, which is just one more, but it would be like a million, and we would not have to do a million rotations. We will just have to know what is the remainder, so like the modulus of dividing a million by 4. So this is pretty important because I'm making this observation because every time we do 3 rotations on a 3 element input, we would end up with the initial setup. So like here, we start with 0, 1, 2. On the first step, it's 2 1s, 2 0 1, 1 2 0, and then again 0 1 2. So every third rotation is the initial setup. So we can basically ignore anything but the difference. And if the difference, like if this is 3, so if the 3 divided by 3 like has 0 remainder, then we can basically just return the initial input. But if it's 1, then we just need to do like here. If we try to divide it, we can fit 3 only once in the 4, and we have a 1 remainder. So we only have to do this 1 rotation to be able to solve this question. And now, as far as the algorithm goes, if this was a doubly linked list, it would be good enough to do this calculation that I just mentioned, but also keep a pointer from the head that we even have it here. So we already know what the head is. Keep a pointer for the end, and then just the remainder of k number of times, put the end at the beginning, and then take the reference of the previous one. So like here, put the end in the beginning, and then take the reference of the 4. But since it's a singly linked list, we cannot go backwards, we can only go forward. And what this means is, immediately to my head, a stack sounds like a decent solution. So like keep a stack where we put all of the elements one by one, so that we can always pop that stack and know which element is the next last element. I'm pretty sure this solution can probably be solved without a stack also. There are probably some pretty neat tricks. But I think this is the easiest one I can think of, so I'm just gonna go ahead and code it, and then we'll check the other solutions as well. So let's create this 7KT. I'll add it to GitHub as well. By the way, if you didn't check out, we have GitHub, the solutions are in GitHub as well, so you can check them as well as the videos. So let's take this sample code. Actually, I don't need this solution class. I can just use the function. I can have it as a private function to not collide with something else. And I can probably just copy this class as well. But AutoJ is my favorite shortcut, selects the next element of the same type. So now we have this class. I really hate how in Kotlin it's val. Like, why did they have to call it val? Couldn't it be just something else, like anything, just like a v or value or anything? Whatever, just ranting at this point. So yeah, we have this. So what I meant to do, I guess I can keep it like that. Right, It's big enough, especially when I remove the left part. Okay, so I mentioned we need a few validations, so let's just get them out of the way. So if head is no, then return no, because regardless of k, we cannot do any rotations. If head.next is no, return head. So since if this means that we have a single element, so regardless of the number of rotations, we just return this element. We might not need these checks, but they're pretty simple to make, so I might as well add them so I don't think about those when I'm implementing later. So now we have this knowledge. So what I want to do now, I basically want to populate some sort of a stack. So I'm just going to use a double-ended queue, like val deck is a new array deck. I'm going to take the Java one since the Kotlin one is experimental. And it's gonna have list nodes inside. So yeah, I'm just gonna use the Java array deck. And now I'm basically gonna put all the nodes there. So I'll have a pointer to the current node. Var node of type list node question mark, since it's nullable, will be equal to head. And I'll say while node is not null, deck dot add last the node, and we know that it's not null since we're in this check. And Kotlin compiler is thankfully kind of smart, I think, and it's smart casted to list node. Great. So now we have all of them. Actually, what we could do for an optimization, but I don't really care about it much, is let's say that we have this example here where we have k equals 2 and we have 5 elements. So I'm actually gonna take the space for 5 elements, so my space complexity would be equal to the number of elements, which is 5. It could be 5 million, we don't know. Oh yeah, we don't have any constraints. It could be 5 million with k2, so I would be keeping 5 million references instead of 2 references. So what I can do is I can keep a counter of how many references I have stored, since I will never need more references than the last 2 or the last k ones. So as long as k is smaller than the number of inputs, I can optimize it that way. And if k is larger than the number of inputs, then I already optimized it, since I'm using 3. In this case, I'm using the space for 3 instead of taking 4 spaces. So we can improve the space complexity to be the minimum of k and the number of elements. And in my current implementation, it's gonna be just the number of elements regardless of k. And we can improve that later, I think, if we make it work. Yeah, just keeping it in mind, thinking out loud. Okay, so now I have my array deck. What I need to do is I need to make sure, I need to check this, how many rotations do I need to do. So I guess this is also a premature optimization, but I think it sounds very reasonable, so I'm gonna do it, and I'll probably do the other one as well. So let's say val rotations is equal to, if k is smaller than the number of elements, deck.size. If k is smaller, then it's gonna be just k. But if k is not smaller, then I want to, in this case I have number of elements 3, k is 4. I want to do k divided by, or not divided, but the remainder of the division between k and the number of elements. So that would be k percent or modulus deck size. So it will be 4% 3 in our case. Now I have the number of rotations, and basically what I want to do is, well, do that many rotations. So what does the rotation mean? Let's say repeat rotations. A rotation means take the last array deck element, which is so yeah, let's take the last one. So val node. I think I already have a node. Val wast. Why is this? Oh, look, I actually forgot something very important here. My mind is a little bit jumpy, but here we would have done an endless loop because I forgot to say node equals node next in order to traverse it. And that's why it was saying the var is never modified. Thank you, Kotlin compiler. You're amazing. Okay, so back to my initial repeat. So what does a rotation mean? A rotation means take the last one and put it in front. How do we do that? Well, the last one points to no, which means I need to take the last one and make it point to the first one. So 5.4. Oh wait, I need to make 5 point to 1. I also need to make sure that the previous one is pointing to no right here. Do I need to do that? I think I need to do that. And basically this chain here is unchanged. So like 1, 2, 3, 4. 1 to 3 is unchanged. I need to say 5 points to 1 and 4 points to no. Because otherwise I would create like a circular loop or something. So the last is deck.poll last. Poll should like remove the last one. And give the reference in this last element. So now I'm gonna say, so last.next equals to deck first. So this, I think this does not get first, does not remove the first. It just gives me the reference. So this is what I want to do. I can never have a single element, right? Because if I have a single element, I handle it here. I always have at least 2 elements. Which means, yeah, I think it should be fine to just say last.next is first. And deck last.next is no. So those are the 2 steps I'm doing. And then I do not need to change the first. Oh, and I also need to, don't forget to put this at the beginning. So deck.add first the previously last element. Because this is my first step, I'm taking the 5 and I'm putting it at the beginning of my deck. But the next time I'm doing a step, it needs to be a new beginning. So that's why I need to also add it to my data structure here. So last.next is first, deck last is next. So this is the new last. So like I've already taken 5 out, so I'm saying 4, you should point to no. Okay, so I think this is fine. And then I just return it, right? I just return my new head. So return deck dot first. So how do we test it? I need to create some examples. Oh yes, I don't need. I'll just put it here. I'll just use the built-in tests. So let's see if we manage to do it. Okay, so something seems to be working. All right, it's accepted. So yeah, what is the runtime complexity of this? So runtime complexity is first we go through all of the nodes and add them to my array deck, which is O of number of nodes. So we can say O of n. Then I check whether k is bigger than or smaller than my number of elements, and because I do this modulus whateverness, it means that in the end I'm always doing rotations less than number of list nodes. So we could say that it's like k number of rotations, but it's not really k, because even if k is like 1,000,000, if I have 5 elements, it will never be more than 5. Like it will never be even more than 4, because if it's 5, I'll just return 0 and not go through the rotations. So this means that I'm basically having the runtime of twice the number of elements at most. And since 2 is a constant, that I'm basically going through the elements twice. And since I'm going twice, I can just say it's big O of n, and n is the number of elements here. And my space-time complexity is also the number of elements, so O of n. And as I mentioned, I'm pretty sure I can improve the space-time complexity to be the smallest of number of element between number of elements and k, so I can improve that complexity. But the runtime complexity, I think, can never be improved beyond O of n, because there is no way to obtain the last element without going through all of the elements first. So yeah, space runtime is optimal, space can be improved a little bit. So we solved it. Let's go ahead and check the discussion. Java, 100%, easy to understand. So yeah, they're using fast and slow. So I guess let's just check if this is working for them, and we'll see whether they improve. I mean, I'm pretty sure runtime can never be better than OLN, but it might be possible to do, as I mentioned at the beginning. Did I? I might have not mentioned, but there might be a possibility to do space complexity of 1 if you just have a couple of pointers. So they have like temp, fast, and slow. They have length 1, so they're counting the length here. Since they're not using an extra data structure, they need to count the length. Then they do the exact same. Do they? Size. What is size? Where did size come from? I think this is a mistake here, since they're saying size, but size is not defined anywhere, right? They have length. So I think they meant to say length here. So they're doing the same thing potentially. And then length minus equals k. We need to get the last element. So they say for equals length bigger than 1 I minus minus, slow equals slow next. Fast next is temp. So where is slow then? So fast goes to fast next. How many times? Well, it's not no. Oh, I think that's pretty cool. What did they say? We need to take the last 2 elements and put them in the front. So we need reference to the last element and reference to the third element. And the reference to the first element. Okay, so they keep the head somewhere. They have it here. They have a fast and a slow. So they're moving only the fast, and they're moving the fast as many times. So they're moving the fast to the end, and they're counting how big is that, like how many moves did it take. So they're basically counting the number of nodes here, and then this is probably length, because I think they're not they did a mistake here, and then length minus equals k. We need to get the last element. So they're making sure here that k is less than or equal to the length by doing this in the same way that we did it. And then they're saying what's the difference between the length and k. So this is how many elements they need to go back, and then that many times, so like equals length bigger than 1 minus minus, so this is that many rotations. They say slow equals slow next, and slow starts with the head, right? Yeah, slow starts at the beginning. So they're moving slow that many times, and this is just is this an isolated one? I mean, this for loop does not have brackets, so they're moving it that many times, the slow one, and then they say fast.next. So fast is the last element. So fast next goes to the temp. So temp is the head, right? I'm a bit confused. Temp is still the head. So fast points to the head. Head points to the one after slow. And slow.next is no. Wait, fast.next. So this is the end. Oh, so this basically makes a circle. So this creates a circle. This creates a that's really clever. I really like this solution. They basically create a circle, so they remove the no pointer. They create a circular reference, but since they know where they need to do the cutoff, they are cutting it off there. Does it always work though? It kind of sounds like, I mean, I think it works. 1, 2, 3, 4, 5. So they're saying slow is like gonna be here. So they're gonna cut it, and they're gonna say this is circular, and then slow.next is no. Well, I guess they stop here. They have to stop here. So they say slow.next is no. And then where did they move the fast.next is temp. So 5 points to 1. Then temp is slow.next. So this is like temp. And then slow.next is no. So slow was a 3. So 3 is a no. So now they say it's 4, 5, 1, 2, 3, which looks correct. Yeah, that's really neat solution. I like it. My first submission. Nice. Good job. Alright, this was a cool task. Yeah. Thank you everyone for watching. I mean, there obviously is a bigger improvement than what I did. There is the possibility to not use any extra space, since the circular one just uses 2 extra references. So my solution can be improved much more. But I'm okay with leaving it as is. I learned that the circular way is pretty cool. I kind of thought about it, but didn't really deep dive, and I'm okay by just knowing that it exists. And yeah, that's it. See you guys tomorrow. I might look to do those differently. I'm not sure yet. I mentioned yesterday. It might be nicer for the viewing experience if I actually solve the entire question first, like optimally, and then go through the solutions. I mean, maybe not just through the code. Code is still real time, but know what the solution is instead of think here. It might make nicer YouTube videos. Since I still don't plan to do actual editing on these ones, I just do not have the time right now. But it will be not too bad time-wise if I first solve the question and I solve it again on camera. I guess it depends how much value does it bring to be thinking in front of the camera. I guess it brings some value for my future rewatchability if I watch it myself to see how I was thinking and say, oh my god, Victor from 2022. Look at this guy, Victor from 2020. He was so dumb. You're so smart now. You're amazing. That would be nice. But whatever. We'll figure it out. So thank you everyone for watching and see you tomorrow. Hopefully this was helpful to somebody. If not, well, at least Victor from 2022 will have a laugh. Bye bye.